So, one of the most important parts about doing science is communicating your results. It is so important to be able to explain what happened in a given situation, right? That's the whole point of science. That's why we do science. So, what we're going to do every time we do a lab in here is write some kind of a summary. Now, the general procedure for writing summaries in this class very closely follows the Lit 101 strategies that you use in all of your other classes. We've just modified it a little bit to make it more specific to science. Okay, so it's the same strategy, just a little bit different and tweaked specifically for labs. So in a typical Lit 101 scenario, we have an article. What do we do with each paragraph of that article? We annotate it, right? We annotate it with a summary sentence. We are going to do the same thing with the parts of our lab. And so we're going to start up here at the top. Remember, in the first sentence of a Lit 101 summary, we include the text title, the author's name, and the main idea. So who is the actual author here? Well, I wrote the instructions, but that's not the important part. The important part is the data. The important part is the results. So I am going to be more interested in who performed the lab. So instead of the author of the lab procedure, unless you wrote it, we are going to list the people in your lab group. So next is the main idea. What are we doing here? What is the purpose of the lab? We are looking to see how the circumference of a circle changes when we change the diameter in this particular instance. So if the lab has an objective, that's usually a good clue as to what the lab is all about. So you can use that as your annotation. Okay, so what's the next section? It's the procedure. You need to summarize this procedure. Now, depending on how many steps there are, this could be between 1 and 3 sentences. I do not want you to list every single step that is numbered here in the procedure. This is an annotation. This is a summary. So your sentence needs to summarize the steps that you took to get your data. So now we're going to summarize our data. For most people, it is extremely difficult to look at a bunch of numbers on a data table and come to some sort of conclusion. A list of numbers makes my eyes cross, and I know that it does a lot of people. That is why scientists make graphs, and this is why you are going to be making graphs. Graphs are your friend when they come to interpreting data. So in order to better understand what a graph is telling us, we are going to annotate the graph itself. I want you to really look at what each part of a graph means. Now, the main parts of a graph are the rise, the run, and the slope, and the y-intercept. So each one of these parts represents something important about our data. So let's start with the rise. The rise on our graph is how much the line goes on according to the y-axis. In this case, it is the change in circumference. To annotate this, we are just going to make a little bracket between 2 points and label it as the change in circumference. It is also important to note that we measured this in centimeters. The run on a graph is the amount variable on the x-axis changes between the same 2 points. On this graph, the run represents the change in diameter, and again, we measured this in centimeters. This gives us a nice visual of how the rise and the run compare to each other. Now, we do have a linear graph, and so we do have a slope. The slope of the graph is the amount of rise on a graph divided by the amount of run on the graph. Most of the time we are graphing in a program that gives us the value for the slope, so we don't really need to calculate it on our own. So up here, right, this is that slope form equation in a very general form. This 3.57 is the value for our slope. So make a note of the value of the slope and include the units on this label. Remember, we have no naked numbers in this classroom. Always, always include units on a number that you write down. Okay. Now, one of the coolest things about the slope of a graph in physics is that it typically represents a property. Do you know what the relationship between the diameter and the circumference of a circle is called? It's pi. The slope of the graph that you created defines that property. Now you might notice my slope here is a little bit off from the accepted value of 3.14, but we'll come back to that. So in our discussions, we will get around to what property is represented on a graph. So be sure to include that in your annotation. The last part of the graph is the y-intercept. This is where the best fit line crosses the y-axis. But what does it mean in terms of our data? On this graph, it tells us the circumference of a circle when the diameter is 0. So what is a circle with no diameter? It's a point, right? Does a point have a circumference? It does not. So what should our y-intercept be? It should be 0. So if we have a diameter of 0, we should have a circumference of 0. So our y-intercept makes sense that it would cross at 0, 0 on this particular graph. So what does it mean if it doesn't? If you look here, my line, my best fit line is going to go a little bit below 0. What does that mean? That means that my data is a little bit off. Okay, our intercept should be 0, 0, but my data is a little bit skewed. Okay, so that's something to think about as you're looking at your y-intercept. Not all graphs are going to have an intercept of 0, 0. So keep that in mind when you're making these graphs. So what are some other important things to take note of? Right? We've annotated the parts of our graph. So what are some other things that we might take note of? This is a straight line on a graph. This is a linear relationship, which means we have a constant rate of change. We call this a constant relationship between the diameter and circumference of a circle. So that's just something else to make a note of. Even though we have a straight line and we know that it's a constant relationship, sometimes it's a good idea to just write that down so you don't forget about that. Now on to the summary. Before you get started, think about conventions. This is a writing assignment, so complete sentences, use your spell check, and use MLA format as a structure for your document. This picture is also attached in your classroom assignment, so don't try and copy it down, but do use it as a guide, right? This should look familiar. This is your Lit 101 picture, and it shows you how to set up your name, your teacher's name, your class name, the date, the title, and then some things that you need to include in your summary. All right. So the first sentence uses the title, partners, and variables in the first complete sentence to summarize the lab. Check back with your annotations. Use those annotations to craft your first sentence. So here's an example. In the circle lab, Fred, George, and I determined the relationship between the circumference of a circle and its diameter. Right? That sentence sets up the whole summary. The second sentence is a summary of the procedure. Now again, it is possible with longer procedures that you might need to add another sentence or two. But it is a summary, not a list of steps. So what did you do in this lab? Well, the circumference and diameter of different circles were measured in centimeters. Right? That completely summarizes everything that we did in this lab. Now, for this particular type of summary, you are going to want to include a picture of your graph. You're going to be citing your graph and referring back to it in your summary. So you want it there as a picture for people to refer to. So go find your graph, take a screenshot or make a copy, and put it into your summary. It can go at the bottom of your summary, or it can go in the middle when you start citing it. It's up to you, however you prefer to do that. But go find your graph, make a copy, put it into your summary. So now for the hard part. You're going to summarize the relationship between the variables in the lab. Notice the word cite is the first word of these instructions. You need to talk specifically about your graph and your data. So just like in a Lit 101 article, it is important to cite specific examples from your data. Start out that next sentence with the citation. According to the circumference versus diameter graph inserted below. Okay, now what? What are we trying to explain here? It is best to start with the overall relationship. The graph shows a linear relationship, so we can say that the circumference of a circle increases at a constant rate as the diameter of the circle increases. Okay, that's a good first sentence. You're really summarizing the relationship between those two variables in a really concise, simple way. We can also give the exact rate of change. We know the value of the slope, so we can explain that. Give me a number. What is the rate of change? Okay, in this case, it was 3.57 centimeters per centimeter. We also know from our discussion that the slope is defined as pi. I do want to point out here that we are citing a lecture in class. We could also cite information from the textbook or another source if we really wanted to verify that. So a good next sentence really defines what the slope is and what the actual rate of change is. As discussed in class, the slope of the graph is defined as pi and shows that for every centimeter increase in the diameter of a circle, the circumference will increase 3.57 centimeters. So that tells us what the slope is, what property it represents, but also what the rate of change is. So if we increase the diameter of our circle by 1 centimeter, the circumference is going to increase by 3.57 centimeters. Now, this is an optional part. If you choose to, you can write the slope form equation that describes the line on your graph. If you do, you would want to include the mathematical relationship in your summary. And if you choose not to write the mathematical relationship, that's fine. You can just skip this part. But a good way to say that would be mathematically the relationship between the circumference of a circle and the diameter of a circle can be described using the equation C equals 3.57 centimeters per centimeter times D. Now, the last sentence of the summary is a concluding one. A conclusion sentence refers back to the main idea and summarizes what we know. It does not include any new information. Make sure anything you have in this sentence has already been mentioned and explained in your summary. So as shown in the Circle Lab, there's a constant relationship between the circumference of a circle and the diameter of a circle. That's a good conclusion sentence. And there you have it, a Lit 101 summary, science style.